1b on the review, and the one thing you had to notice about 1b is that there was no plain old constant at the end. There's no number out here at the end like plus 11. If there was, you'd have to try to use that rational root theorem or take a look at the graph to see where the zeros might be. When there is no constant on the end and you notice that they all have an x in them, factor out said x. If they all have an x in them, factor it out. Instead of saying factor it out, maybe I'll use the term undistribute an x. Pretend that try to get this to look the way it would have looked before an x was distributed through. All right? So if you had a set of parentheses with an x out front, that x cubed would have been an x squared. And that negative 9x squared would have been just a negative 9x. And the 22x wouldn't have an x with it. It would just be minus 22. So that's the first step when you notice that they all have the same variable in common, and there's no number on the end. The number on the end messes that up. So you can't do that technique in C. In C, if the 30 wasn't there, you could do the same thing and factor out an x. But the 30 messes that up. All right? The minus 30. Now that we're here, you can kind of just leave this little x by itself while you try to factor this the way we've done in the past. And I can't remember ever using 22 and 9 in my life as an example. But does anybody know the two factors of 22 that differ by 9? 11 and 2. So you have a minus and a plus, or a plus and a minus. The order doesn't matter. But the numbers that you assign those signs to matter. You need to have the negative with the 11 and the 2 with the plus, so that when you do your inside-outside, you get a negative 9x. So we have successfully factored this completely, and what would cause this x to be a 0 if that x was 0? What would cause this set of parentheses to be 0? If that x was an 11, it would produce 0. And what would cause this to become 0? Negative 2 would produce 0. That concludes 1b.